All right, you guys remember what a polygon was?
Oh no. No.
Polygon? You guys like that O right there?
It's a 6.
Okay,
Looks like a fishing pole.
a polygon is a flat shape. It's got to have straight edges, basically. It's got to be closed. So like a pentagon, triangles, rectangles, all those things. Those are polygons. Poly means many, many sides. That's what this means, polygon. So that's not what we're doing in this chapter. We are doing, I can't remember if we've talked about this in a previous chapter. We're doing Polyhedra, which means
Three-dimensional.
Yeah, three-dimensional. Just like polygons, so this box, yeah. Come on now. This box shape is an example of a polyhedron, that's singular. But just like a polygon, it's got straight edges, it's closed. You guys remember what convex and concave meant for this?
Like this.
Concaves have caves, so if it went like that, that would be concave. Convex doesn't have a cave. So this assignment is about convex polyhedras and no caves. Have we talked about polyhedra before? I can't remember. No, probably not.
They've done like
So-
tetrahedrons.
Oh, yeah, that's right. Yeah, tetrahedron. Yeah. Yeah, we have. We have, I remember. This is called a rectangular prism because the bases, the top and the bottom, are rectangles. Yeah, a prism is like if you take a triangle or rectangle or a pentagon or whatever and just stretch it into the third dimension, that makes it a prism. At the tops and the bottoms are. Anyways, one of the things we're talking about today is vertices. What do you think vertices means? We've used this. Yeah, corner points. Corner points. We've used those for polygons. We've talked about those for angles. They're corner points. So how many vertices does this rectangular prism have?
8.
Yeah, how many are on the bottom?
4.
And how many are on top?
4.
So altogether there are 8. And then, what are you thinking edges?
The lines between two vertices.
Yeah, it's these line segments that make up the corners.
12.
So how many edges are on the bottom?
4.
How many edges are on the top?
4.
How many edges
4.
are lateral?
4.
4. 4 plus 4 plus 4? 12 edges on
What
this
do they
side.
have all those 4s for?
I don't know. Vertices, edges, and the last one
Faces.
is faces. Have we done this before too? It's all vague in my memory.
6.
Faces means the sides, the flat surfaces. So, how many surfaces, how many sides on the bottom?
1.
1 on the top, 1, and how many lateral surfaces?
4.
1, 2, 3, 4. Front, back, left, right. So top, bottom, front, back, left, right. That makes 6.
What are
Okay. Huh? Edges are the line segments, like the things that make the
lines in between a
yeah, the lines between the faces. All these are edges, like the edge of your table, right? The edge of this. The lines on the edge. Okay. So there's this guy. I think I kind of forgot, but I think this name is pronounced Euler. Euler's might be Euler. I can't remember. I need to Google the pronunciation. I feel like it's Euler. Euler's.
Euler? Yeah, it's German. Right? I think it's pronounced Euler.
Okay, I'll Google it later. We'll see. Anyway, it turns out on any convex polyhedron that if you do the vertices plus the faces minus the edges, you always get 2. Euler's formula. So on this one, that would be like 8 plus 6 minus 12 equals 2. Should work out that way every time.
Yeah.
Interesting. Okay, anyways, that's,
Do we even need that? Wait.
well, we're gonna use it a little bit, yeah.
So it'll always equal to.
Basically, yeah, you add the 2 small ones together and minus the edges, the big one, and it should always be 2. If you counted it right, it will work.
Oh.
Now, if you count it wrong, and it doesn't equal 2, then you know you made a mistake. All right, now we're ready. Number 1. True or false? Euler's formula can be written as f or v plus f equals e plus 2.
False.
Okay, if we add, I got about half from class saying half. Okay, if I add this e to this side, what will it turn into? It'll be v plus f equals e plus 2, right? So that is, number 1 is true. If you said true, you were correct. Okay, number 3. So it says state the number of vertices, edges, faces, and then do Euler's formula. Show that Euler's formula is true. Okay, on number 3, I'm guessing some of you have counted already. What shape is on the top there? Octagon, 8 sides. So how many vertices are on the top? 8. It's got 8 edges, 8 vertices. How many vertices are on the bottom?
8.
8. Are there any vertices in the middle?
No.
No. So there's 8 plus 8. 8 plus 8. So I'm just going to put v equals 16. Remember, vertices means corners, corner points. It asks for edges next.
Yeah.
Okay, how many edges are on the top?
8.
Also 8. How many edges are on the bottom?
8.
8. How many edges are lateral going up and down?
8.
8. 8 plus 8 plus 8, 24.
We ate a lot.
Marianne liked that one well.
What?
Lisa made someone's day brighter.
What? I don't get it.
He missed it. He
That
said
one
we ate
wasn't a
lot.
joke.
There are a lot of 8s that we consider. Are you telling me that I eat a lot?
No, never mind.
What?
I don't get it.
Yeah.
It's okay.
Okay, on number 3, how many faces are on the top?
1.
1 on the bottom.
1.
How many
8.
lateral faces are there?
8.
8 going up and down. So altogether that makes
10.
10. And then it said we're supposed to use Euler's formula, show that Euler's formula works. So on this one it's 16 plus 10 minus 24. Does that actually equal 2? Yes, it does. So we did it right. Yay, we're geniuses. What is that number? Number 5. Okay, vertices, corner points. How many, you guys counted the bottom yet? How many vertices are on the bottom?
Which one is this? 5? 9.
9. Okay, do you guys remember what a 9-sided polygon is called?
Nonagon?
Nonagon. Sounds kind of like 9. Nonagon. So there's 9 on the bottom. Are there any more?
Nope.
There's one on the top.
One on the top. So altogether we've got 10. Okay, so if there's 9 sides on the bottom, how many edges are on the bottom?
7.
Nope. 9. If there, yeah, 9 sides on the bottom, 9 edges on the bottom. And then how many
9.
lateral edges are there? Right, from each
So 18.
corner point on the bottom, there's a one coming up. So yeah, there's 9 going up and down laterally. So that makes 18. 9 on the bottom, 9 on the sides. All right. And then we need faces. How many faces are on the bottom?
1.
1. How many faces are going up?
9.
9.
So 10.
That makes 10 altogether.
So 10 plus 10 minus 18 is Can you help on 6? Can we get some help on 6? Because I tried applying Euler's to one, it doesn't.
Didn't work.
It didn't work for me.
You made a mistake. So just think of it as like
Well, I've gone
top.
over it again.
Think of it as top, middle, bottom when you do stuff. Okay, number 7. Actually, on 7, let me give you guys. This one's probably the trickiest one because those dotted lines and stuff. Dotted lines means it's in the background, right? So why don't you? I'm gonna give you guys a minute head start on 7, and then we'll check it and see if you got it right.
And the fog.
Mr. Jordan, just ask a question. What's the sector formula? Like the sector area?
It's not on this test.
Is that not the bonus?
No.
Oh.
Even if it was, I wouldn't tell you though.
Well,
It's a bonus question. I'm not gonna help you with that.
No, it's not.
Yeah,
It's
I
like
finally erased that over there. Okay.
It's like it's flipped in the back. Usually this.
Yeah, just
Oh,
look.
and it's a triangle on
You
the
just
top.
gotta look at the lines. Just trust the lines.
Yeah, that's why it's a triangle on the top.
Are there decimals in the answers for your question?
There might have been 1 or 2. I can't remember. I think there might have been 1 or 2.
Yeah, I'm pretty sure because I'm getting some.
Okay, lost my place. Number 7. So the vertices. So how many vertices are on the top of that shape?
3.
3. How many are on the bottom?
5.
5. So altogether there were
8.
8 vertices. Okay, and then the edges. How many edges are on the bottom?
5.
5, because the bottom is a pentagon. Did you guys see that? 5 on the bottom. How many edges are on top?
3.
3. And then you got to count all those lines going up and down as edges
8.
also. 8 in the middle. So the bottom is 5, the top is 3, the lateral up and down is 8. 5 plus 3 plus 8.
16.
And then the faces. How many faces on top?
1.
How many faces on bottom?
1.
How many faces going up and down?
8.
8. So 1 plus 1 plus 8. Got it? And then we do have to write the little equation thingy, so
8 plus 10 minus 16.
So today's lesson is kind of about using our 3D imagination so we can kind of picture, because it kind of gets confusing when you have a 2D image of a 3D object sometimes, especially if you're not a professional artist like me. But yeah, that's kind of what. So actually, I'm going to help you guys with these drawings. So we're going to go to number 8 next. So on number 8, what they want us to do, it says sketch the intersection of the solid bounded by the surface and each described plane. That sounds pretty confusing. Basically, what they want us to do is draw that triangular prism for number 8 and 9, and then draw the whatever they describe. So on number 8, the way I draw a triangular prism is I start with my triangle on the top of the prism, and I draw the 2 front lines down, and I draw the back line dotted down, but not quite as low.
So you have 3 lines of the same length, but one is dotted. Pretty much. At least when you go down and then you have the triangle at the bottom. Maybe it's the same movie.
You can just look at your picture on number 8 if you, that might help more, I don't know. Okay, that's not what we're doing on them, that's just the first part of number 8. What we're supposed to do is draw a horizontal plane through. You guys know what a horizontal line is? Yeah, like the horizon. So if I took a sword, or I use my ninja skills here, and I chop like that, what would that cutout piece, like if I broke it open, what would it look like? That intersection that I cut out. You guys know? Yeah, it would be a triangle. I'm going to change colors to make it look better. So what I'm going to do, if I chop like that, it'll be a triangle. So what I'm going to do is I'm going to put some dots here to kind of outline what the triangle will look like. It basically looks like the top and the bottom of the shape. Then I'm going to connect those dots like this.
Can't draw anything 3D.
So can you imagine me, if you took a sword and like chopped through horizontally, it would make a triangle in the middle. The book colored this part darker. I'm not sure on the smart board it looks better, but probably not. Having a different color probably looks more than. Anyways, number 9. Okay, number 9, we're supposed to use the same shape. I'm gonna repeat the process. Alright, this one, I think they said vertical chop, right? Vertical plane parallel to BCFE. Okay, BCFE is this guy in the back, or this plane in the back, right? So basically I'm chopping like that, kind of like this angle, parallel to this back plane. You guys know what shape that would make? Yeah, hold on. Let me change colors. Yes, you're correct. Yeah, I think I got it. So here's what I'm going to do. Kind of got to outline my plan with the dots there. And I'm going to connect them and I'll make a rectangle. If this is a rectangle, why does it look slanted? because it's three-dimensional. It's just, that's how perspective works.
Can't.
If we were looking directly head on at the rectangle, it would look more like a rectangle. But if you're looking to the side of a rectangle, like when I'm looking at the smart board, its shape is kind of skewed. It doesn't look actually like a rectangle, even though I know it is. What? Let's just put it in the box, I guess.
Also negative direction.
Yeah. All right. Kind of this. Anyways, moving on. Number 10, we're supposed to draw the, what's that shape called?
Pyramid.
Pyramid. Rectangular pyramid, might be a square pyramid. So on this one, I start with a normal triangle in the front, and then I draw a third line going kind of back. That. Not my best pyramid. Not a big deal.
I'm gonna sit
Might be better served by just copying the one they drew in the book.
It's like that.
Too late. Okay, on this one they say that they want a vertical plane right through V, which is the vertex, the high point of the pyramid. You guys know what shape that's going to make? Triangle is correct. Let me switch to red. So it's going to go right through V, and it'll also cut like right through here. So it looks kind of like that. Slice it right down the middle. Are you done?
Oh, this one's pretty good. Almost.
Your drawing worked out well on this one.
Yeah. Pretty nice. I haven't done the back stuff though, or like the dotted lines. Yeah.
Okay, 11 is another pyramid. Whoops.
Because this one.
11's another pyramid, so go ahead and set one up again. Better pyramid for me.
That's pretty nice.
Oh, that looks square.
As long as you read it right. Yeah.
Alright, this one says, this one says a vertical plane, a vertical cut parallel to RQ, which is the bottom right segment, not going through V. So basically I'm gonna slice vertically on the right side here. It's gotta be parallel to this guy. So we try and use my imagination to see what's gonna happen. Trying to draw this right below it. What shape do you guys think that is?
Rectangle.
Rectangle. Could have drawn my line straighter here. Let me see if I can clean up a little bit. Whoops.
You're straightening up.
So I just dropped my dots straight below because it's a vertical cut. Like this cuts here, goes down, this cut goes down. Then connect those dots, trying to make it align straighter a little bit. think number 12 is also a sketch. Make a sketch showing a
There's a
plane.
lot.
Okay, number 12 says cylinder. So what's cylinder?
2 circles.
3 sides.
Yeah, it's like a tube, right, or a can or something. So I start with an oval, go down, curve the bottom. You guys have to, did Mr. Steele
Yeah.
make you draw stuff? Anybody take an art this year? Do you have to do it?
No. Not at all.
Yeah, I would have been surprised. All right. Okay, it says make a sketch showing how a plane can cut a circular cylinder to form each section. So how could we cut this and make a circle out of the cut?
Go in the middle.
Horizontal, yeah, right down the middle. So it's just basically, when you cut it horizontally, it'll just cut out a circle.
It's not half the same as it used to be.
So it looks kind of like the top and the bottom. This is 12A.
And then you get a rectangle.
Okay, and then the next one say rectangle or kind of
Yeah.
How do we get a rectangle cut? Ernest?
Vertical.
Yeah, push that. Yeah, vertical cut will be rectangle. Let's see.
So just pretty much.
So here's what I'm gonna do. I'm gonna make some dots to help me figure it out. So if I make a vertical cut, it would like hit right there and right there on those lines. And on the back side, kind of the same thing, right? Actually, I need to turn my vertical cut this way so I can actually see it. So I'm gonna back up, because I don't want it just to be a line. So I'm gonna make my vertical cut more at an angle like that. So it's kind of sideways a little bit. Alright.
Can you make an
So
oval
probably
if you did a
top
diagonal?
and bottom are the exact same. So we get a-
Yeah, if you do a diagonal, it makes an oval, yeah.
Too bad they asked us to one of the.
the plane.
Oh my goodness.
So maybe like a cube and just putting that in the middle. Mr. Gordon, do you think I'm right on number 13?
We'll find out here in a second. Do we have like 8 minutes? How much time we got?
we got a 55.
55 or 50?
Yeah, 55. 8 minutes. Are you sure for
8 minutes, okay.
We only have
Okay, we're fine, we're fine. Okay, on 13 it says, identify the cross-section of a cube formed by each described. So basically, what cut are we gonna make if we have a parallel plane through a cube?
Oh, I was right. Let's go.
Are we drawing?
No, you don't have to draw it. If I cut a parallel plane, what will the cross-section be? Square. You don't have to draw this one, it's not a drawing question. I'm just drawing it to help us have a reference. So 13 is squared. Okay, 14 says a plane containing the left front edge. Okay, what's left front edge?
You said number 14?
Yeah. Left
Rectangle?
front edge, so it's a plane containing that. And what else did it say? The back right edge. No, I didn't draw it back. Oh, it's over here.
Rectangle.
Yeah, it's cutting diagonally through the.
Oh, yeah, that makes sense.
So I I guess you would be able to see that line. This line would be dotted. But yeah, what shape is that?
Rectangle.
Rectangle.
Probably Mr. Odell's class.
Sounds familiar.
Probably like the movie soundtrack.
Okay, and then on 15, a plane containing the diagonal of the left face. What does that mean? Okay, on this one, I'm gonna say this is the front, so this will be our left over here, just so we can see it better. So it contains a diagonal on the left face, so that blue line is the diagonal. And what else does it have?
Only
A vertex on the right face. The right face will be like over here, so I'll just say it's like right here. If you said triangle, you are correct.
Either triangle.
14, we said 14 was a rectangle. I didn't write it down.
When they, the way they word it confuses me,
'Kay.
but after you draw it, it's
Yeah, you gotta think about it very slowly. A diagonal on the left side, so this is a diagonal. Now the left side would be like over here, but I just said it looks like that front. Anyway. 16, this one's the hardest one. A plane and it's our last one. A plane containing a diagonal of the top face. What do you think they mean diagonal on the top face?
A diagonal on top.
Diagonal on top. Floppy diagonal. And then, what else? A segment on the bottom that is not a diagonal. So, this would be a segment on the bottom.
could that be a 3D shape on the inside?
Wait, what?
Quadrado.
It's like curving.
Happy good.
Would that still be?
It is
would that be a
curved.
rectangle?
I've never
Ain't nobody.
Would that be like
Can we
the
just say like
curved
quadrado?
Maybe I read that. Here, let me read that again.
That is not that.
Curving.
Make it like-
Oh, David.
Rectangle.
Like a 45.
Okay, they didn't say this. A segment on the bottom, and it has to be parallel to make it anything. So, like right here. So it would be like this.
I'm glad we're here.
David.
What's that? Be a rectangle?
No, no. Okay, on the
Oh wait.
my picture's not great, but
Trapezoid?
here, let me make it better. Let me draw on the back side. So if I went from like, I need a parallel line to this, or else it won't make a parallelogram. So if I make it from like here to here,
Oh yeah.
okay, can you guys see it a little bit better? Yeah, it's a trapezoid. It looks kind of like a little bit like that. Trapezoid. Yeah, because when you said it, I screwed up my drawing. So.
Oh, this is Jordan.